Hi guys, this video today is going to cover a review of graphing quadratics. Anything that you need to know about graphing quadratics, I'm going to try to cover here in this video. So we have the three different forms, standard form, factored form, and vertex form, and I'm going to work my way through and hopefully explain everything you need to know for each form. So let's start off with standard form. First thing you do in standard form is that you use the equation x equals negative b over 2a. That will give you your axis of symmetry. Then you take that negative b over 2a and you plug it in for x and you solve for y, and that gives you your vertex. So in your vertex, your x value is negative b over 2a, and your y value is, when you plug it in, what do you get? To find the y-intercept, you plug in 0 for x and you solve for y, which in the case of standard form will always just be c. So yes, you plug it in, but as it turns out, if you plug in a 0, you're just going to get c. Okay, how to find the roots? We have not learned that yet. We're going to learn that in the next part of this unit, but for now, we haven't learned it yet. So let's just take an example, take a look at this, and let's go through some of these things that we just did. The first thing I did is I said negative b over 2a. So a is 2, b is 8, and c is 6. So I'm going to take negative 8 over 2 times 2. That's negative 8 over 4. That is negative 2. So my axis of symmetry is x equals negative 2. Always write it as an equation. Don't just abbreviate it or whatever. Just write it out as x equals negative 2. Then, that's my axis of symmetry. To find my vertex, I'm going to take that number, which in this case is negative 2, I'm going to plug it into my original equation, and I'm going to work it out. So if I plug in a negative 2, I'm going to put this into my calculator or do it mentally and come up with an answer. And so when I plug that in, I get y equals negative 2. So my vertex is the point negative 2, negative 2. Okay, I have enough information here. I can start graphing. So I'm going to start plotting some points and putting my axis of symmetry onto my graph. Okay, so I went through and plotted my axis of symmetry, plotted my vertex. I'm going to pay attention to some other things here. Because it is positive, it opens up. If it opens up, that means it has a minimum point. The minimum or maximum value is the y value only, which in this case is negative 2. The domain is always negative infinity to positive infinity. Now, I'm going to hold off on the rest of it until I can get some more points here. So another point that I know from standard form is the y-intercept, and that is 0, 6. And again, give it as a full coordinate. Don't just abbreviate it. And so I'm going to go ahead and plot that point at 0, 6. If I have one there, I can come over here and give the reflection. So there I have it there. Now, I do need a couple more points, and there are a couple of different ways you can do that. One is you can always go back to a table of values. So you can just create a table of values and maybe choose negative 3 and negative 1, or positive 1. You just pick whatever numbers you want and plug those in. That's one way to do it. But kind of a shortcut that we've been talking about is this 1, 3, 5 pattern, that all parabolas will follow this 1, 3, 5 pattern. However, this one starts off with a 2. That means we need to take our 1, 3, 5 pattern and multiply it by 2, and so our pattern becomes 2, 6, 10. Okay, so we're now going to go up to right 1 and give our reflection, and up 6, right 1, and we plot that point, which is already there. So that just a little bit, it kind of confirms that we've got everything correct. If we had it already and we do it by the 1, 3, 5 and it works, then we're good. Okay, so your parabola should look something like this. So now we can talk about some of the other answers on our text box here. Our range is from negative 2 to infinity, and we include that negative 2 because it is part of the range. The number of solutions, that means how many times does it hit the x-axis. And in this case, it hits it twice. Roots, that's asking me where. Where does it hit it? I can give that as an equation, x equals negative 3 and x equals negative 1, or I could give the points, negative 3, 0 and negative 1, 0. Increasing and decreasing. Remember, we always use the x values for increasing and decreasing. So from 2 to infinity, it is increasing. And from negative infinity all the way to 2, it is decreasing. And that is in the x value. So I know it starts from up here, but on the left, it's coming from negative infinity. The end behavior on this one is both are positive infinity. On quadratics, parabolas, they will either be both positive or both negative. Okay, that is standard form. And I went through and filled out this whole text box for you. On the next ones, just to make it a little bit simpler, we're not going to do every single thing. I'm just going to go through it and then graph it with you. Okay, the next form is factored form. When we have something in factored form, the factors give us what the intercepts are. And the reason that we're changing them to negatives is because really what we're doing is setting these equal to 0. So if I set x minus 1 equal to 0, then I would get x equals 1. And if I set x plus 3 equals 0, I would get x equals negative 3. And so that's why when I graph these, I'm going to graph the points positive 1 and negative 3. Okay, so what I do is I take those and I plot those points. Let me take a second to plot those. So these are my x-intercepts. My axis of symmetry will go down the middle, which I can just count on my graph, and I see that there's 4 boxes in between here, so I can just go over 2 boxes and make my axis of symmetry. I'm going to make that dotted. Okay, so there I have my axis of symmetry. So let's just go back. The way it is algebraically is p plus q divided by 2. So I could have taken 1 plus negative 3 and divided by 2. And that's negative 2 over 2, which is negative 1, and so I draw my axis there at negative 1. Or you can also just do it like I did it a second ago, just count over to the middle. Either way is fine, but that's how you find the axis of symmetry. Then to find the vertex, whatever that number was, so we took p over q divided by 2, we take that number, we plug it in for x, and we solve it for y. So I'm going to take that, which is negative 1, I'm going to plug it into this equation for the x's, and I'm going to figure out what y equals. So a negative times a negative is a positive, and this is 4, and half of 4 is 2, so this is a positive 2. That means that my vertex is at negative 1, positive 2. Okay, so let's just go over a couple more things here. We have our axis of symmetry, we average them. We plug it in, we solve for y. The y-intercept is the same rule as always. That is, we plug in a 0 and we solve it for y. I'm going to do that down here. I'm going to erase some of this. So if I plug in a 0 and solve it, then I have a negative 1/2, 0 minus 1, 0 plus 3. And a negative times a negative is a positive, and so 1/2 times 1 times 3 is 1.5. And so my y-intercept is at 0, 1.5. I can graph that right here. And this is, I'm going to zoom in a little bit more, but this is also where that 135 rule comes in. So we have 135, but we also have this negative 1/2. So if we take a negative 1/2, we have 1/2, 3/2, 5/2. And some people aren't really sure how to do that. And so let me zoom in so that we can see what's going on here. We're going to count from our vertex down 1/2 over 1, and then down 3/2 over 1, and then down 5/2, which is like 2.5 over 1. So every time you're always going over one box, but it's your up and down, your y values that change. So you're going down 1/2, down 3/2, down 5 halves, and so forth. And you could go on to 7 halves, 9 halves, and whatever, but all we need is 5 points, and so we're good to go here. And so you should be noticing that if it has a 2 as a leading coefficient, it's a little bit narrower. If it has a half as a leading coefficient, it's a little bit wider. If it has a 3, like this one, it's going to be even narrower still. So that's what that leading coefficient does. It determines the width of the parabola. Okay, so there's our parabola. Finally, on this one, our roots are just P and Q. Remember, you have to change the signs. So +1, -3. This form is the only form that we know how to find the roots for. The other ones, we can kind of accidentally get it if we count up or count down and it falls on the exact point, but sometimes we don't know it. Okay, let's talk about vertex form. Vertex form in a lot of ways is the easiest form. The axis of symmetry is x equals h. It's just given to you right here. Almost anytime you have parentheses, the sign is going to change. So this one was a positive P and a positive Q. This one is a positive H, but this one, this K, does not change signs. Okay, so our vertex is H and K. Finding the y-intercept the exact same way as we always do. We plug in a 0 for x and we solve it for y. And then again, on the roots, we don't know exactly the roots for vertex form. Okay, let's take a second and graph this. Okay, the vertex here on this example is at 2, -12. So I need to plot that point. So I'm going to move my axes so that it all fits. Otherwise, we just get into, it's hard to find the place on the graph. So let's go ahead and graph 2, -12. And so the way I put my axes, it is right at the very bottom of my graph. That's 2, -12. Let's go ahead and put our line of symmetry in there as well. Okay, so here's our line of symmetry. To find the y-intercept, I'm going to go ahead and show the work, even though you might not have to show the work, but this way you know what it is. Okay, my y-intercept, I'm going to plug in a 0 for the x, and I'm going to work it out. That's going to give me 3 times 4 minus 12, that's 0. So my y-intercept is actually at 0, 0. And I can make my reflection point over here. Let's talk about that 135 rule. Here we have it's multiplied times 3. So if we're going to take 135 and multiply that times 3, that's going to give us 3, 9, 15. Okay, I know I can't go that far, but I can go up 3, right 1, and do the reflection. And then the next one would be going up 9. So I'm going to go up 9, and that lands me on that same exact point. And then my next one would be up 15. So this is really going to be a pretty narrow graph here. So there's my graph. You can see, hopefully, can you tell this is narrower than this one, and it's even narrower than this one, because that leading coefficient determines how wide or narrow the graph is. Like I said, I did not go through all the things on the left. You should be able to do that, though, for all 3 forms. If you want some help on finding some of those out, if there's things that you don't know, please come in and get help before the quiz so that you're able to do well on the quiz. And that's the end of our video. So now hopefully you're able to graph any form of a parabola regardless of the form I give it to you in.